can you solve this math challenge? Here's the question. Solve for all possible values of x that satisfies this equation square root of x cubed plus x squared plus 1 plus square root of x cubed plus x squared plus 2 equals 3. Now you can pause this video if you want to give this problem a try. And now let's answer this question together. Alright, so our goal here is to solve for all possible values of x that satisfies this crazy equation having two square roots. When we say all possible values of x, we can say that x must be an element of the complex number. So our answer is not limited to the real numbers. Alright, so we have square root of x cubed plus x squared minus 1 plus x cubed plus x squared plus 2 equals 3. Alright, now one thing we notice here is we have a common term of x cubed plus x squared on these two terms. So why not replace this with another variable, and let's call this as n. Therefore, we can replace those terms with the variable n to make this simple. Alright, now we have an equation square root of n minus 1 plus square root of n plus 2 equals 3. Now, we can square on both sides, do the squaring again to eliminate the square root and solve for the value of n. But another method, what I like to do is to get this equation and let's rationalize. Now, here's the main reason why we do that. Again, let's rationalize this. So, let's multiply this by its conjugate, square root of n plus 2 minus square root of n minus 1. Now, if we do that, our numerator becomes square root of n plus 2 plus square root of n minus 1 multiply by square root of n plus 2 minus square root of n minus 1. And seeing this, we can use this identity. If we have a plus b times a minus b, this can be simplified to a squared minus b squared. So the numerator of this fraction must be equal to square root of n plus 2 raised to the power of 2 minus square root of n minus 1 raised to the power of 2. Now, square root of n plus 2 raised to the power of 2, we can cancel out the square root and this 2. So this is just n plus 2. And we can cancel out this 2 and the square root. So this is just n minus 1. Now, distribute this negative sign. This will give us negative n plus 1. Now, positive n, negative n cancel out. This is just equal to 0. And 2 plus 1, this simplifies to 3. Now, we know we have 3 over 1 right over here, so why not cross multiply? So, if we do that, we get 3 over 3, or simply equal to 1, must be equal to square root of n plus 2 minus square root of n minus 1. So, again, this is just 1. And we know that square root of n plus 2 minus square root of n minus 1 must be equal to 3. And using these two equations, what we notice here is what if we add these two equations? So we can easily eliminate this expression positive square root of n minus 1 and negative square root of n minus 1. So we can easily solve for the value of n. So now, if we do that, we get 2 multiplied by square root of n plus 2 equals 3 plus 1 must be equal to 4. Now, let's focus on this result. Then, divide both sides by 2 to solve for the value of n. 4 divided by 2, this will give us 2. And let's square on both sides. So, the left-hand side is just n plus 2. And on the right side, we have 2 squared or simply equal to 4. To solve for the value of n, let's subtract 2 on both sides. So we have n equals 4 minus 2, and 4 minus 2 is definitely equal to 2. Now, this is the same thing if we use squaring method. Alright? Now, we know that n equals 2, but n is also equal to x cubed plus x squared. So we can equate x cubed plus x squared to 2. because they are both equal to n. And we want the value of x, not the value of n. Alright. And to solve for this, let's equate this to 0. Now, one thing I notice here, this negative 2, we can write this as negative 1 minus 1. Now, the reason why we do that, because if we split this, we arrange a little bit, we have x cubed minus 1 and x squared minus 1. Now, this x squared minus 1, we can use this identity. This is simply a squared minus b squared, because we have x squared minus 1 squared. So we can factor this as a plus b times a minus b, or x plus 1 times x minus 1. Alright, so using this identity. Now, how about x cubed minus 1 or 1 cubed? We recall this identity. If we have a cubed minus b cubed, this can be factored as a minus b multiplied by a squared plus ab plus b squared. This a represents x and this b represents 1. So this can be factored as x minus 1 multiplied by x squared plus x plus 1. Now, we can see a common factor of x minus 1 right over here. So we can now factor out x minus 1. If we do that, we get x minus 1 multiplied by the remaining terms. We have x squared plus x plus 1 plus x plus 1. We can simplify this also. We can combine like terms. X plus x is 2x and 1 plus 1 is 2. So now, our equation becomes x minus 1 multiplied by x squared plus 2x plus 2 equals 0. Now, let's use the 0 property. So we can say that at least one of them must be equal to 0. So we have x minus 1 equals to 0. We have the first case. And the second case is x squared plus 2x plus 2 equals 0. Now, in the first case, we can easily solve for the value of x. Let's add 1 on both sides. So x is definitely equal to 1. So we now have the first value for x. Now, how about the second one? X squared plus 2x plus 2 equals 0. This equation, this quadratic equation, is not factorable. So we will use the quadratic formula. We have negative b plus or minus square root of b squared minus 4ac all over 2a. This is very familiar to us. Now, this a, the variable a, represents the numerical coefficient of x squared, which is 1. This b represents the coefficient of x, which is 2. And this c represents the constant term, which is also 2. Now, let's replace all a with 1. And then this b with its value 2. And this c with, again, 2. Now, let's simplify. 2 squared, this is 4, minus 4 times 2, this is 8. So, 4 minus 8, this will give us negative 4. And square root of negative 4, this is equal to 2i. So, this is just 2i. And negative 2 plus or minus 2i, if we divide this by 2, we get negative 1 plus or minus I. And this is our second and third possible values of x. Therefore, we found 3 possible values of x that satisfies this equation: square root of x cubed plus x squared plus 1 plus square root of x cubed plus x squared plus 2 equals 3. Wherein our answer, x equals 1 or x equals negative 1 plus or minus I. And as always, we are done.